It's recording, but it won't record your guys' face.
Okay, so where are we at? Okay, so if you look at arginine, okay, you have 2.2 as a pKa for the first carboxylate group, right? Do I have to drop? You guys, you know.
No.
Okay, and then NH3 has 9, which is really basic, and then you have the side chick or the side chain that is super duper basic. So because of the fact that your side chain is very basic, it's closer to because it's closer to this one, you have to choose this one. So I'm trying to think this a better way to explain it. The way that she explained it to me is if you look at this, right? Okay, if you have so if it's neutral, the PI is very easy because you take 2 and you divide it in half and you're fine. So let's go through, let me choose this one. Let's look at aspartic acid. When we had aspartic acid, we had 2.1, 9, and then 3.9. So yeah, so then what she told me, this is directly from her mouth, and you can ask her about this too if you want. She told me between they choose between here and here and here and here. I remember this is what she said. I remember her saying that you have to choose the 2 that are closer. So if it was for aspartic acid, you choose these 2, 2.1 and 9.8. But if we're looking at arginine.
But wouldn't these 2 be closer in numbers?
Yeah, sorry. So you would choose these 2. And then if you have something that's extremely base, wait.
But arginine, I choose 2.2. What I did.
Yeah,
I
you choose
had
2.2 plus 9, and then you divide it and you get a half. She told me that if you have a side chain that's basic, you have to find the 2 that are much more closer.
In number.
Yeah, but
I mean,
still not a good explanation though.
But
So I
it's
want to make sure I'm
neutral.
Huh?
We're trying to find a neutral.
We are trying. What was the question? This one is for just finding the isoelectric point. So
What's the PI?
yeah, the PI of arginine. So
It wouldn't be.
let me ask of the why again. I'm going to ask her this again of why you choose. Oh, what she explained to me is that the R group that's closer to the amino group, you choose those as the
Those are more
iso.
important than
I guess so, but I
Yeah, because
it still doesn't explain
the whole
why.
thing is I thought there was this is an iso point and this is an iso point, right?
Right. But you have
So-
3 in this case.
Yeah.
Where your R group, so for example, if your R group is really basic, then you choose the really basic R group and then the NH3 and you divide those in 2.
Do we need to know that arginine is a basic group? That's why it's because here is 10.8, the PI.
Yeah, but it was given to you though.
The PI.
Yeah.
It was 10.8.
Yeah.
Really? Where?
Right here. Oh, wait. Oh, do you need to know that it's people? No. You don't need to know that it's people. You need to know that you see that the side chain is incredibly basic and the amino group is also very basic, and you would choose out of these 2 because if you're doing an isoelectric point, you're adding 2 points together. So, but which one are you going to choose? You're going to choose the one that's closer.
Yeah, I do that.
But I want to make sure I explain that right because
The
between this
reason
one-
why.
yeah, because say if you're doing aspartic acid, then do you choose these 2? Do you choose this one and this one and this one and this one? So let me find a better way to explain that.
Yeah, I should ask her.
But that's how, yeah.
Because why did she choose for arginine?
She did make that one extra credit.
12.5. Yeah, that's it.
So yeah, let me take a picture of that real quick and then it was so good. Let me get my phone real quick and figure it out.
I need to remember this.
Okay. So I'll find a better way to explain that one. She made that one extra credit for a reason.
It only shows the PI. This is PI.
For Argent?
For everyone is 10.3. Unlike, how do I balance it?
Yeah.
Oh,
But
it's
it's not-
because of the, like, she was saying this part, but I don't know the whole reason why,
Oh,
but.
why?
Why would
Yeah,
it be
yeah.
I don't know why.
But I totally get, it's probably like the side chain minus the end, like, that's how I'm just gonna call it.
The side chain minus the end.
Well, the end.
The mean,
The side
okay.
chain, yeah.
No, I feel you, okay.
So I'm pretty sure that's what it has to do with,
Because-
like, if we probably do, let's say lysine,
Uh-huh.
what's,
9.2.
Lysine right here. Yeah, so for, if you chose lysine, you would
that's
do,
4.5 plus 5.25.
oh, are you cutting it in half and
Yeah,
adding it together?
then
Oh,
that's
you're
how you do
weird.
it.
Why? Oh my god.
I put in little divide, and I was like, okay, I can't do this, so I just
Oh.
have to cut it in half.
Oh, you put in a little divide. You want me to calculate? I couldn't be done. Like, it was the next time I'm bringing a calculator. Because I was like, I don't want to do simple math.
Yeah, but it's 10.8. If we add 5.0 plus
Yeah.
12.5.
And the reason is because, like, okay, let me see if I can show you a quick trend.
Wow.
All right, this one, we know we just add this in half. Okay, and straight up. Add it together, divide in two. For this one, which two will you add? This one and which one else?
But how do you know which one to add?
Okay, so
That's my
this one,
confusion still.
because you add the two that are closer.
They're
together.
closest together to the same number?
Yes.
Oh, okay, but to
But
find
then-
the PI?
wait. I think so. Okay, this, let me see, make sure I have this. These two you add together and divide into. These two you add together and divide by two. These two you add together and divide by two. Going up here, these two you'd add it together and divide by two.
9.2 and 6.0 added together divided by 2.
I'm gonna say, yeah, because,
So 10.8 plus 4, 16.
yeah, I wanna know why.
No, it is the N in our group, because I did that, and it is 9.75, so it is the 9.7.
For which one?
Lysine.
It is?
Yeah, it's the N
It's
plus.
these two, right?
Yeah,
Okay, what about for glutamic acid?
I did the one for lysine.
Oh,
Is,
yeah.
is glutamic acid 4.3 plus 9.7?
For lysine,
Give me those numbers again, real quick.
For, let's do glutamic acid, 9.7 plus 4.3,
9.7 plus
4.3.
23.
Mm-hmm.
And then let's look here, glutamic.
glutamic acid, 3.2.
It's 3.2?
It's 7.
But for the PI, it's 3.2.
The PI is 3.2?
3.2. It says right. And I got
Okay,
this for my
then do
organic
9 point-
chemistry books.
Then do
It says
9.7 plus 2.2. Let me try to explain that right.
6.4.
What is it? It's neither?
6.4.
Which one?
Oh, sure.
9.7.
Because glutamic acid is glutamic, right? Glutamic?
I'm gonna ask about.
Yeah, yeah.
So this is the type of questions that you would bring to her when you go to the professor office hours. Because I'm not even sure about that. I just remember she taught me that one that way, and I'll make sure I'll
I'm
ask
just gonna ask to this.
that. Okay, next one.
Let's move on to
I'll do
number
that.
7.
I think 7. The next one I had asked on was 11,
11?
which is like a simple pKa question. And then the pKa, the smaller it is, the bigger the acid. Or no. The smaller it is, the more acidic.
Right.
That's where I got messed up.
Okay, I can do this one.
No, but I understand.
you
I
understand?
understand
Okay,
it. It's
never
just like I got confused and I thought the pKa was bigger.
Oh.
It
What
was-
number?
Number 11, yeah. Yeah. The way I remember this one is it in the list one here or no? It's in the list here. The stronger the Ka,
Mhm.
the opposite is the pKa.
So
And the stronger the acid,
the stronger.
right?
Yeah.
So if they flip this up on you, then your Ka is weak. Then you know right away your acid is weak. Then you have a weak acid.
So the stronger.
But then your pKa is going to be the higher one. So whatever the highest number is in the pKa.
Okay.
So just remember this. Don't even worry
Yeah, I
about
was
this
like,
one.
that one looked all confusing.
Don't worry about the bottom. Okay, if she asks you which is the strongest acid, and she gives you a Ka, then you have to see, okay, this, and then these are all numbers given to you. These are numbers given to you,
So
right?
the stronger the K, the weaker the pK, the less the pK.
Yes, it's opposite. So she flips this one on you and says, okay, I'm giving you a weak acid.
It's gonna be.
Then what is it?
the-
Don't look. Tell me.
Okay, so if it's gonna be weak acid, it should be the smaller the K, the stronger the pK. No.
That's right. You're right. So you're matching it up. You match it up with this one. It'll be opposite. Or you can, if you want, you can write it like this too. Big Ka, big strong acid. And then the one that's a weirdo is the pKa. Does that make sense? If you memorize this, when she asks it, she can ask it in any way. You'll know the answer. Is that clear? Okay. Promise? Okay. Next one.
Are we doing number 7? Did I got number 7 right?
I think it was 12 and
No.
13. They're like,
12 and 13? Let's do 12. Okay, 12. Are we doing 12?
yeah.
Okay. The Kc value for two, why did you do this one? Okay, two
Oh, yeah.
phosphoglycerate, okay, these two large molecules is less than 1. This is the one I wrote on the board before the
You
test.
did?
Remember? Yeah, I wrote this one on, and it was on there for a minute before she erased it. Okay, so all she was trying to get you to see is that the K value is less than 1.
And then
The
flow
reaction
lines to
is-
the left.
Yeah, so you got that?
Mhm.
Okay, that was fine.
So the K value is less than 1.
Yeah. Did you get that one?
I got this one wrong, this one.
Wrong? Okay. So we'll go through this real quick.
I got both of them.
That's okay. K is equal to 1. Do you know what this means?
No, what does K?
Equilibrium.
Equilibrium.
Yeah.
So K is equilibrium?
No.
Oh, okay.
But yeah, it wasn't.
K, when K is equal to 1, that is when your equation is at equilibrium.
So what does K mean?
It's products, or products,
Yeah, you're right. Products over what?
reactants.
Right.
So K means products
Over reactants.
over reactants.
Mm-hmm. And that's the concentration of the products over reactants. So if you have K and you have K, so K comes from this. You can have a Ka, you can have a Kb, and you can have a Kw. All right. Your K is the products
So we can-
over the reactants. So when you have your equation, you have your reaction that's going back and forth and it's reacting, then you'll have a certain concentration of reactants and you have a certain concentration of products. So when K went, like say, right, you put in numbers for this. If K is equal to 1, that means you have a certain number, like basically you can have 2 over 2. 2 over 2 is 1.
Mhm.
So that means you're in equilibrium. So then what about when K, so this is K of an acid, K of a base.
So it will be equilibrium if it's 2 over 2 because it's equal to 1.
Right. But this is just any number, right? It doesn't have to be, So you can choose any number as long as they're equal on top of it'll be 1. So, but what about when K is greater than 1?
So that's for KB, right?
It could be Ka, it can be Kb, it doesn't matter the K. Just think K. Just think K.
Okay.
K is the equilibrium constant. K is equal to they usually write it like this, KEQ, and that's the equilibrium constant. It's just a constant. Just like we have a whole bunch of Planck's constant, we have all these different constants in science. This is an equilibrium constant, okay? So what's the next relationship? When K is greater than 1.
Delta G.
What?
Delta G.
Oh, I'm talking about in terms of which way does it lie?
But doesn't it deal with delta G?
It does deal with delta G, but not this problem. The problem is asking the K value for this phosphoglycerate and phosphono-pyruvate is small, less than 1. It's asking, does it lie to the right? Does it lie to the left? Is it, it's asking which way does it lie? It does talk about energy too, but it helps to know this relationship before you answer this. Okay. So if your K is greater than 1, right? If something is greater than 1, that means, say for example, you have no, I have to do division. If you have 4 divided by 2, you're gonna get 2, and so it's greater than 1, and so the way this relationship that exists, remember when she wrote this on the board? K greater than 1 means that you have your products are favored. Remember products?
Means that your products are favored.
Yeah, your products are favored, and it lies to the right
Products
on an equation.
favored. So for the previous one, which is the equilibrium, is this K is less than 1?
No, that means K is equal to 1.
Okay,
So yeah, so you have K is equal to 1. Let me do this so it's clear. You have K is equal to 1.
so for
You
this
have
one,
K is greater than 1, and you have K is less than 1.
So it will
Okay.
be like this. K is equal to 1 for this one. That is it. K is greater than 1 when it's equals to 2.
Yeah, but that's just an example, right? That's not that's just, so you can see the numbers. So then when this constant is greater than 1, then the equation lies to the right, and you make products.
And its products are favored.
And then when it's less, it's the opposite. You only make the reactants. Remember this right here? These are your products. Which ones are your products?
For here,
Yeah, out of this equation. Which one's your products?
the pyruvate, that's the product.
Right. Which one are your reactants?
The phosphoglycerate.
Yeah. So if you have K is greater than 1 and you make products, what are you making more of?
Pyruvate.
That's right. And then if you have it less than 1, which is pretty much the opposite.
Which has there are more products than reactants.
If you have less than 1, then what will you have?
More
More reactants. Yeah, more reactants. Does that kind of clear it up in terms of how they're related? Okay. I know that one is weird. You have to look at that concept over and over because that one is a toughie. Because it's kind of weird to think about K and then 1. Okay, 1 is equal on both sides. That means it's you having an equal forward reaction and equal backward reaction. Doesn't mean you have it more so means that it's talking about the reaction rate. So if it's 1, it's going back and forth at a normal rate. If it's anyway, so that's the relationship.
Okay.
And so that's why for number 12, the equilibrium lies to the left because K is much less than 1.
So we include B.
Okay, 13, now we're talking about G. Was 13 fine for you or no?
I got it wrong.
Okay, that's all right.
Reactant.
And my main thing was because delta G was a negative, so I thought it would be non-spontaneous.
Uh-huh.
What did I go for 13? I got it wrong too. It's supposed
So I
to be
put that it
C.
favored the.
Let's see if I even got this right. No.
You got it right.
Yeah.
Okay.
There's a couple here too, so.
Like, just kidding. I'll counting them.
Yes.
Let's see. Okay, the reason. Okay, I'm gonna try because I remember this one was a toughie too. Delta G for the reaction is negative 31.4 kg per mole. What is true about the reaction? All right.
I don't even.
All right. This is when you have to switch gears and talk about delta G in terms of the relationship between delta G and entropy. I can see how this can be tough because for this
You
one,
have to think about it. Because, like, okay, delta G.
because
delta A,
she's jumping from concept to concept,
Yeah.
but she's adding a whole bunch of extra stuff, which is clouding the judgment, unfortunately. So, but it's okay. Delta G for the reaction is negative 31 it's negative 31.4 kilojoules per mole.
So that's delta G equals to 31.4.
Right. Now, look, what do you see here about this number?
A negative sign.
Right.
Negative.
So you see a negative sign. All right. So what do we know about
Delta G.
yeah, in terms
Free
of
energy.
right, is delta G is free energy. And if it's negative,
Then the entropy is positive.
then the entropy is positive, right? Right. And then if delta G is positive, then entropy is negative,
Negative.
right? So, but what else do we know about delta G? We know that in an delta G for this equation,
Something about randomness. So organized, disorganized.
come on, brain. Oh, enthalpy. Minus T delta S.
Yeah.
You guys remember this equation? Okay.
Yes.
So, okay. Do you guys remember about spontaneity?
Spontaneous and non-spontaneous.
Right, so-
Non-spontaneous.
Exactly. So if you have a spontaneous process, delta G is positive or negative?
Spontaneous. Negative?
Right.
Because your
So-
body is spontaneous.
Right.
You'd be a negative person.
I
I'm just kidding.
love it. Delta G is spontaneous if it's negative.
Mhm.
That means the reaction occurred, like, look, this right here, is that a spontaneous or non-spontaneous reaction? Fake reaction.
Non-spontaneous.
It's, wait, let me try it again. Let me know, did I have to put any work to do this?
Yeah, because you have to think about it.
Okay. Before the thinking, this is why this is a horrible example. All right, okay, now I picked it up. Is that spontaneous or non-spontaneous? Okay, let me do it like this. Ice melting, spontaneous or non-spontaneous?
Wait, what?
When I put a glob of ice here, what's gonna happen?
It's gonna melt.
It's gonna melt, right?
But it's gonna be like independent, right?
Huh?
It's gonna be independent since the ice cube is not thinking about it. So it's
It just happens, right?
happen
So,
naturally.
When something happens naturally
Mhm.
in science, it's associated with a spontaneous process. Like if I put a huge chunk of ice here in this temperature,
Mhm.
it's considered spontaneous. Okay, so, and we call the delta G is negative
Delta G
because
negative.
it's releasing energy.
All right, so this is what I'm understanding. So
Okay.
when something is happening naturally, such as the ice cube, it's
Right.
melting, that's gonna be a spontaneous delta G negative.
Yes.
Okay.
And so what do you see here?
So it's gonna be negative.
A negative sign. So when you see a negative sign, what can you assume about delta G?
It's gonna be a spontaneous.
Spontaneous. And that's why the answer to number 13 is it's spontaneous. We can go through why everything else is wrong, but
So C.
times it, yeah. Does that make sense?
Is
Mhm.
All that extra stuff was just to throw you off. I kid you not. Because you don't need to know, okay, you have the delta G for the reaction of a phosphonoloprovate to pyruvate is negative 31.4. And then you have to find about what's true, okay? We read each one. The forward reaction is not favored.
The
Um,
forward reaction is
Can
not
we,
favored.
how do, the forward reaction is not favored. So if the forward reaction is not favored, let's look at K. Okay, K, right? I told you if it's equal to 1, then it's at equilibrium. And then I told you if it's greater than 1, then products are favored. Is it greater than 1?
Because it's negative 31, no.
Right, it's not, so you can ignore that,
Mhm.
right? Okay, what's the next one? The reaction requires free energy. That means requires energy.
But it's negative 31, it wouldn't require anything.
There you go, because it's releasing energy. Perfect,
Wait,
so you get rid of that. There you go, no, you got it right.
no, but because it's negative, it wouldn't need energy.
It doesn't need energy.
doesn't.
Remember, delta G is
Oh, it's free energy.
is negative, it releases energy.
Yeah.
When you see a negative sign. That means like a bomb explosion.
So
It's
releasing
releasing so much energy through combustion. So delta G is negative and it's releasing energy. But when you need energy, delta G is positive or negative.
Okay, so negative, delta G is negative release energy.
When you need energy, delta G is positive or negative.
Positive.
Positive, because you're adding energy. You need energy. You have to put in work to make it happen.
It's only
That's why that one is wrong, because this is releasing energy.
B, right? That one's wrong because the ratio
Mhm.
where is free energy.
Then you go to this equation. That you know that a negative delta G is associated with a spontaneous process because it naturally happens. The ice naturally melts. You don't have to put any energy into it, right? Breaking bonds, negative, releasing energy. Making bonds, putting energy in to make those bonds positive. That's how I remember it. Is it perfect? Maybe not, but it'll get you a good grade. So, no, I'm just kidding. I do want you to understand the reason behind it. And we can go over that one more again, if you will,
Yeah.
later. First, let me just throw this on charge because I have a meeting with my counselor in 15 minutes. Shoot. Phone is gonna die. Did I leave I left my bag in there. Did you guys see like a tan bag?
In the office.
Yeah,
In this class.
in class, yeah. I have to go back and get it. Oh God, I have to do the walk of shame. All right, do you guys want to do another question before, because I have to meet with my counselor.
Let's see. Let's do 1D. During short distance rather masses production of lactic acid. If yield is high, why might hyperventilation before it dash be used?
Which one?
D.
D for what? Question.
Number 28.
20, okay. I was like, D, which one? Okay. During a short distance run, the muscles produce a large amount of lactic acid. In view of this fact, why might hyperventilation before a dash be useful? Okay, so when I'm hyperventilating, okay, what just happened there? I'm expelling what?
Oxygen.
Okay, I'm expelling CO2, right? So as CO2 decreases and CO2 is blown off, it becomes, well, let's first look at what happens to the equation when I blow off CO2. So here's the CO2 here, right? I'm blowing it off. So it will cause it to go away, right? So pretend like you're removing it from the equation. So if I remove something for the equation, Le Chatelier's principle says what needs to happen
So remove
in terms of stress. So, and then I'll
It'll shift away. It'll
Okay,
shift towards.
it'll shift towards.
I mean, where
Okay.
are we putting the CO2? If we're removing the CO2, where are we gonna put it?
Just know that it's gone for now. Okay, because you're blowing it off, right? It's not completely gone because there's always like a small trace level, but for Le Chatelier's principles, okay, so I'm breathing out, CO2 is removed, right? What does Le Chatelier's principle say?
When you put a stress on something,
Uh-huh.
it shifts to the left or shifts to the right.
Try that again. You're right, but it's probably better to say shift away or shift toward, right? Because if I'm putting stress on you, you're gonna shift away. We don't know left or right yet because we don't know what's happening on the other side.
Okay,
So shift away or shift toward. If I remove something, you wanna shift it towards, right? Because you wanna fill that gap. Okay, so remember that. Now think about this. I'm blowing off CO2. Okay, I'm blowing off CO2. So now look at the equation. CO2 is on the left side of the equation, on the reactant side. So since CO2 is gone, which way is it gonna shift? And I remind you, if I remove something, Le Chatelier's principle says I have to fill that
so
gap.
you're shifting away. Is that?
I'm gonna explain it one more time. Okay, don't worry. So if I put stress, if I add something on this side, it'll shift away. But if I remove something, there's a hole now, and the hole has to be filled. So if I take something out, it fills. If I add something, it'll shift that way to fill it. So now I removed CO2, which way is it gonna shift? Exactly. It's gonna shift towards. Okay, so that's one part. Now we have CO2 shifted towards it, and it fills the loss. And then now what's gonna happen to the hydronium concentration? Look.
You would increase.
Well, let's look at this. So now I have to take more of this, and I have to take all of this from here and shift it that way. And so, what's happening to the hydronium ion?
It has to increase to fill the
Tell me why you think it increases.
because it has to go towards
So
to fill this gap.
if it's
right?
going to fill this gap, I'm talking about what happens to this side. Does it increase or does it decrease? Because this is going over here,
So it's gonna be.
so it's going to decrease. I know it's weird. You have to think about it. You're right. It has to increase over here, but it decreases on this side. Does that make sense? Okay. We'll probably have to practice some of these a couple times because they're kind of bizarre. But because of the decrease on that side, it has to go and fill that hydronium ion.
I see what you're doing.
Sure. And the previous one I jacked up, so don't.
And that'll be Brian. But it says.
How did you say it? How did you word it? You got 4 out of 4? Oh, 1 out
No,
of 4.
1 out of 4.
Hyperventilating keeps CO2, which cause an acid state. Oh,
Oh, we do D or C?
I don't know which one.
B.
I thought we were doing D.
28.
I've been reading C.
Oh, it's all good. Oh, you were reading C? Oh, no wonder you're so confused. No, we're on D. We're on D. Yeah, that's what.
Oh,
God. So wrong. Oh my God. Okay. So, what is it? Oh, no. Sorry. So that hopefully cleared it up. We were talking about D. So, whatever. Don't listen to my explanation of D for C. Okay.
So.
Yeah.
I thought the more CO2 you take in, the more acidic your body becomes.
Oh, it depends. I feel like it depends on.
But it was
Mine
depending
is-
on the question, the way the question was set
It's
up.
the way it's worded. So you can't, unfortunately, that's what I came to realize. You cannot rely on that because it depends how it's worded. if they worded from the point of hydronium or they worded from the point of CO2, then it'll be different.
And the hydronium is the lactic acid.
Did she talk about lactic acid in this one?
Yes. Where is my text? Yes.
Oh yeah, I see.
Yeah, because she mentioned
During
during short
short
distance.
I guess so, yeah, I guess so.
So because we're keeping the CO2 in
For D?
for D, because we're keeping the CO2 in, it's becoming basic, and when we add the lactic acid, it's gonna be its own buffer.
Wait, so lactic acid is going to be.
Yeah,
Say that one more
acid
time
is
so I make sure I understand.
So,
Because we have the acid in,
well, no. We're breathing the
CO2
CO2
off.
off.
Yeah, because we're breathing it out.
I'm
So CO, yeah. That's how I remember it. CO2 is breathing off, so.
So hyperventilating is not letting the CO2 out.
No, hyperventilating is releasing CO2. Because remember, when we breathe, we oxygenate our lungs, but we're breathing off CO2. We're breathing CO2 off.
So the more CO2 you breathe out, the more acidic your body's gonna become.
Okay, you wanna understand the relationship between pH here, right? You wanna understand pH. Okay, so from this side, right, we're hyperventilating, CO2 is decreasing. Okay, so that has nothing to do with pH yet. CO2 is blowing off, the above equation will shift to the left. Why? Because look at hydronium ion. Hydronium ion is shifting to the left, Sorry, I didn't mean to do a Beyonce reference, but there we are. So hydronium ion is shifting to the left. It is decreasing in hydronium ion, which means the pH is increasing.
With the
Basic,
pH.
becoming basic. Did you get that, or did you get acidic? You see how this side of the product side is shifting to the left to fill the gap of CO2.
So everything shifts that
So
way.
everything shifts
And
that
so
way.
because
And so since you're decreasing the amount of hydronium ion, it's becoming more basic.
Shifting to
If you have a decrease of hydronium ion, of the ion, then less acidic is more basic.
okay, I understand now,
Okay.
because the whole thing is shifting.
The whole thing is shifting.
And then this is just taken out. It didn't matter if it was acidic or not.
Yeah.
But what about
It just
the
wanted
lactic
to, she just
acid?
wanted to see if you understood.
That this
How
was gonna turn
hydronium is-
basic,
Mhm.
and then this was gonna turn basic, and then if more acid was added, it'd be a buffer.
Pretty much. Yeah.
And what is the
Get
lactic
that.
acid?
Yeah.
But
Exactly.
because when I went to her thing,
Uh-huh.
I asked her, I was like, okay, for this question, she goes, oh, well, CO2 is taken out, then you're gonna become more acidic. So I just remembered that.
Oh.
And then, so
she asked it another way.
Yeah.
I noticed she did that with essentially everything that you learn here. from yesterday or from Tuesday and Thursday, however she teaches it, practice it the way it's oppositely. No, not the way she does. Practice it the opposite end. So like with this PKA, learn it the opposite way, because that's how she'll ask it. She's not gonna give it to you straightforward.
So what is it supposed to mean with the lactic acid? Like,
It's just identifying the acid. You don't have to know the formula for acid, but if you see acid, what is acid? What's an acid?
an acid, like a donor.
A what?
Donor, right?
Yeah, what donor?
It donates products. not
Exactly,
donor.
it's a proton donor,
Donor,
and the base is,
acceptor.
and so this is an acid. Okay, it's hydronium ion. They write it like this too, but this is kind of a lazy way to write it. All right, that's your acid.
Okay.
She wants to know your effective acid. If you know what happens to acid, whether it decreases or increases, you know how the pH is affected, you know how, if it's too basic, you know, as long as you understand what's happening to here. Same goes for OH, but it looks like she's just focused on H3O. So if you see lactic acid, aspartic acid, if you see glutamic acid, if you see any acid, as long as you see acid behind it, you know, this is what she's talking about in terms of the hydronium ion for the most
So
part.
that's acid.
That's
H3O
acid.
plus,
Mhm.
H plus is basic.
H plus is wait a minute. Say that again. Is H plus basic? You tell me.
Yes.
What is a base? What does a base look like?
Is-
Oh, base is always OH,
Okay,
right?
And H is acid.
Say what?
H is an
And
acid.
H is acid.
and
Mhm.
H is acid.
Mhm.
Yeah.
OH is associated with base. This is called hydroxide. Hydroxide.
Hydroxide.
This is your base. This is your acid.
This is donor.
This one is a toughie. It's a toughie, but it's okay. What's up? You gotta
No.
dip. Okay. Sorry.
I was just.
I know. Don't worry. We'll do better on the
It's
next
fine.
one.
The whole thing is like I get everything,
Yeah.
and then I just fucking blew it.
No. It's not that. It's not that. It's like
Inches.
I think there may be some anxiety there.
Yes.
And the ways to remedy that is to learn it backwards and forwards. You know what I'm saying? Like, even though she teaches it like this way, she'll test you the opposite way to make sure you know it. And you see, I still even made mistakes here. If I knew this backwards and forward, I would have got 100%. All right, yeah, I still got an A, but there's still areas where I have gaps. So it doesn't matter. You just have to learn it backwards and forwards and have it post in different ways so that we fully know it.
So know it the opposite way.
Yeah, no, it's the
How
opposite way.
she
Like-
shows.
Like, you see how I asked this question? I asked this one. How did I ask this one? She asked, which of the following has the strongest van der Waals? Then how did I ask it? Okay, so which of the following has the weakest? Because I made it opposite because that's how she will probably ask it on the final. She's not gonna give it the same way on the final. And if you memorize it one way, she's gonna test you the opposite way, and then you're like, what the heck?
What? Either
Yeah.
or this.
'Cause that's what What else?
Oh, like for example, number 12.
Well,
She-
let me see.
Yeah, like for number 12, she teaches us about the K based on one.
Mhm.
K.
She didn't, right?
No.
She didn't do that K.
The K.
You just have to know.
Mhm.
So it's weird. Yeah. Anything else on this? You guys don't beat yourselves up too much. This one's a toughie. I'm not gonna lie, this one was tough. This one was tough. There's no doubt about that, but we can do this. Okay. I have a meeting with my counselor and she's gonna tell me what I need to do with my life. For real, because applying to med school,
It's not easy.
it's not easy. I have to do some volunteer work, which I'm happy to do. I just have to find a place that will take me and let me help out. And then I'll do everything. But if you guys want to study this weekend, everything that she went over today, I still have to stay here and learn everything what she taught today because I'm not really familiar with all of it. And I can share what I learned and what I remembered and retained with y'all. And then we can have it like, down pat.
Yeah, I'll shoot you an email and then
Okay.
we can like go over the
You
homework.
said that last time.
No, I didn't.
I'm getting defensive now because I want to study with you guys. And I want you guys to do good. I want you guys to do well. And I want everyone around me to even get better than me because then I can learn from you and we'll go back and forth on the board. So really hit me up. I'm down for studying. You can't tell, like attacking you right now.
Okay, so what should I do? Because I'm not gonna be here. I mean, tomorrow morning.
Where are you going? ¿Dónde va?
Tahoe.
Where?
Tahoe.
When are you
Lake
going back?
Lake Tahoe. I'm
Are you
going for
for that event?
What event?
Spartan. Yeah.
Oh no, I thought she was going for global.
No. The globe. I'm doing the global with Spartan.
Where's this at?
Spartan events. It's
Oh,
just
running?
Running.
Damn. Okay.
Do you care about placing?
What?
Do you care about placing?
No.
My coworker was all mad because he didn't place where he wanted to.
No, yeah, just I go there for fun and for
Yeah.
me to like see
My cousin did it
strengths,
one time
my
too.
strengths.
Man, no, that's crazy. Have fun.
Jumping
You're
in
awesome.
fire. Jumping in fire.
Yes.
That's cool.
And the water has swings. I don't know. I'm anxious, to be honest. I'm not. I don't
Yeah,
know.
no.
I'm gonna die.
Don't say that.
No.
Say I'm gonna beat this thing.
Beat everyone.
If you repeat that you'll get number one every day,
I'm gonna
30 times, 100 times a day until you take it, you will be at least in the top 10.
1.5. I'll beat this.
Alright, bye. I'll see you guys. My boss is really calling.
Okay, I'll be number one.
Great.
I still
I'm
have
just kidding, I'm just
Halloween
kidding.
pictures. I have like a whole photo shoot yesterday.
Are you serious?
Yeah, instead of studying, because obviously I'm not studying.
I don't even want to say. Let me want to get together this weekend.
I'll email you because I have your email.
Oh yeah. You have my number?
I don't have your number.
Oh, you can take my number. Am I being weird about my number? I used to be weird.
Yeah, I know. I was like, maybe she doesn't want to give her her number. I have her
It's
router.
because I changed it. Like I know this is weird. I changed my number like once a semester. It's just weird. Okay, 858 231 231. Sorry, 231 3007.
Oh, I know. You changed it.
I know it sounds weird.
No, but I know.
231 3007.
3007.
Yes, sir.
Because every semester you meet personality date.
No, that's not true.
I don't talk to them.
Oh my god.
But before study.
This is my steady phone.
It's not.
My study group.
Okay.
Next semester another study group.
That's how it actually feels like. It's kind of sad.
Yeah.
So,
Yeah, it is.
when do you get back?
Sunday night. So I'm leaving Friday morning. I have to come back on
So then it's Monday that you're gonna study then?
Yes.
Okay.
But I'm thinking of
You'll probably be
reading my
tired on
notes,
Sunday.
but I don't think I'm gonna have time to read them.
Just listen to the lecture. Okay,
Yes,
no,
send me
gotcha.
the lecture.
Oh, you record the lecture?
Yeah,
So you think you can send them to me?
yeah, I can send them to you. Did it send the other one come through? Oh, that's because the other one didn't even record. So, you recorded it? No, you're in the back, so you can't hear.
I can hear.
I mean the lecture. the lecture. Why do you sit on the way back? You're so far away.
I don't know. It's just that's what I said last time in the class. So I was like, I'm listening there again.
Sit next to her in the front.
Yeah.
I promise you, like, I know
don't
this.
bite. Maybe I can probably I'll scare you.
Is this mine?
That's mine.
Okay. I was
You can.
like, that is mine.
Is it
I
yours?
know it's just.
Oh no. Okay, cool. Oh, the race is right there.
Baby. Oh, that's cool.
During what?
Not that.
Is it really?
Yeah. Do you know that there's
That
like
racer seems like
electronic refrigerators? Like,
What?
come on.
what?
That you can talk to your refrigerator, like, open.
I was like, make me some.
Make me a sandwich. I'm hungry.
When I get my money up, I'll have like a maid. I'll have a chef. I'm not kidding. That's the type of life I want. I'm kind of far from it right now, but it's. I'm getting too lazy.
In
Just
my
for the-
50s, at least, like, someone that just me trouble everywhere.
Oh.
And at least in my Netflix, it's just trouble.
What'd you say?
In my Netflix, just a trouble.
I know. Let me start popping them out.
Now I'm always thinking like this. I'm gonna trouble. I'm gonna trouble. I'm gonna trouble.
That's right. I don't think it's good. Anyway, let me get my life, y'all. I'll see you guys in a little bit. Or I mean next week. This weekend, if you guys want to get together, I know you'll be gone. Let me know. I'm kind of a Starbucks junkie.
What's your name?
What's my name? Me, I'm Stephanie.